Warm greetings of the day to all the members of the committee. Myself, Saloni Sharma, Associate Professor in Physics and also Head of PG Department of Physics in Raj Mahila Maha Vidyalaya Jalandhar. I did my graduation in 1994 from DAV College Amritsar, and my post-graduation, I did my graduation in 1994 from DAV College Amritsar. After that, I completed my post-graduation in 1996 from the School of Physics, Punjab University, Chandigarh. I cleared CSIR and UGC NET examination in the very first attempt in June 1996. Thereafter, I was selected for the post of lecturership in physics at Raj Mahila Maha Vidyalaya in June 1997. So it is now 25 years I have been working with this prestigious institution. Presently, I am pursuing my PhD in physics in the field of conducting polymers from Punjab Technical University, Kapurthala, and recently submitted my thesis. During my tenure of 25 years in this college, I have been actively participating in various curricular and extracurricular activities. I have taught classes from senior secondary classes to the post-graduation classes, and I have also attended and organized many conferences, seminars, and faculty development programs. During last 5 years, I have published 4 papers in national and international refereed journals, edited 1 book and 2 magazines. I was the editor of the college magazine Science Gravity for 2 years, session 2019 to 20 and 2021. I have also published 3 book chapters, presented 11 papers in various conferences and workshops, attended 28 conferences, seminars, and faculty development programs. I was elected as the member faculty of sciences by GNDU Amritsar. I am also a life member of Indian Association of Physics Teachers and coordinator of a Whiplet Club of our physics department and coordinator of online IIRS ISRO courses. Regarding my research work, I am working on the conducting polymers, particularly polyaniline, for its application in microwave absorption. Conducting polymer, that is polyaniline, is a special type of organic polymer which can conduct electricity due to the presence of conjugated double bond in the polymer chain. Its conductivity can be tuned from conducting to the non-conducting state by reversible doping and de-doping of the material. Hence, they find applications in various fields like batteries, anti-static coating, corrosion protection, fuel cells and solar cells, drug delivery, chemical sensor, actuators, and many more. The extensive use of communication devices generate a large amount of electromagnetic waves in the living space of humans. This emission of electromagnetic radiation leads to the problem of electromagnetic interference, which not only causes damage to the highly sensitive devices, electronic equipments, but also has a remarkable effect, negative effect rather, on the physical health of the people. So a mechanism has to be adopted to shield these equipments from electromagnetic radiations. For efficient shielding action of the material, it should possess a balanced combination of electrical properties, magnetical permittivity, and dielectric permittivity and magnetic permittivity. So the intrinsic conductivity of the conducting polymers in the field of microwave makes them viable for electromagnetic shielding materials. As polyaniline is obtained in the powdered form, so to improve its mechanical strength, we have made the composite of the polyaniline with polyvinyl chloride. The picture shows the synthesis of the polyaniline. This is polyaniline in the powdered form, and this is polyaniline, the composite of the polyaniline in the form of thin film with the PVC. Here you can see me working at IUAC Delhi for irradiation of the materials, my materials formed with gamma radiation. As far I was awarded the Best Poster Award for my poster on modification in structural, optical and thermal properties of the polyaniline and PVC in International Symposium of Functional Materials in 2018. I was also invited as a judge at Pushpa Gujarat Science City for North Regional Indian Young Inventor Challenge. Regarding my work in academics and co-curricular activities in the college, our department has collaborations with the Indian Institute of Physics Teachers, DST through WebNet Clubs, and Indian Institute of Remote Sensing and Indian Institute of Space Research Organization. And we were also awarded bronze certificate from Vigyan Prasad for our activities taken during session 2017-18 and 2018 and 19. I have also participated as an evaluator in the online NAST 2020 competition along with the Delhi group. I have also conducted online training courses in collaboration with IIRS ISRO during the lockdown. Regarding the academics, we adopted the different teaching methodology. The commonly used teaching methodology is the interactive learning, that is the lecture come discussion or the chalk come talk method, and the use of model. Then ICT enabled teaching methodology is there. PowerPoint presentation, e-modules, video lectures, online classes, and even PDFs also. For giving experiential learning to the students, we organize different field visits, and for participative learning, we organize various seminars, workshops, conferences, and various competitions. These are the pictures showing the demonstration of the total internal reflection, differentiating between the converging and diverging lenses, explaining the double refraction through quartz prism, then explaining the diffraction of light of laser in particular by using a thin hair, and hence finding its thickness. So we also have established an innovation lab in our college so that the students can perform experiments on their own and learn through activities. So these are the glimpses of students performing experiments in the innovation lab. We have also set up a model of Foucault pendulum in our college. This is the picture of the students and the teachers of our department demonstrating the Foucault pendulum. In relation to the ICT-enabled teaching, we use PowerPoint presentations. So this is the picture of PowerPoint presentation. These are the video lectures just to the students through our HMV ELMS portal, where the student can log into its student ID, and see any of the lectures put on by the teachers. These are the Google classrooms. During the lockdown, we have tried all our possible ways to reach to our students, even in the remotest of the areas. For giving them assignments and projects, we used Google Classrooms. These are some Google Classrooms. And even some students were there in the very remote areas for whom it was difficult to connect to the Zoom classes. So we tried to reach them through the PDF notes of the books or the topics what we are teaching in the otherwise Zoom classes. So these are some PDF notes I have shown. Being motivated by the model of online NAST 2020, we encouraged our students to perform some experiments from the materials, whatever was available in their home. So these are some pictures of the students performing some experiments in the safe situation of their homes. We have a small departmental library in our department with around 350 books, which we give to the needy students for a period of one session or one semester, whatever is required. To give experiential learning to our students, we organize different field visits. So these are the glimpses of the visit to the ISM Mohali in 2017-18 session, a visit to Pushpa Gujral Science City in 2017-18 again, visit to Punjabi Physics Department, Punjab University, Chandigarh in 2018, visit to Pushpa Gujral Science City in 2019, visit to CSIO Lab in 2019, visit to CSIO Lab in 2020. It is a regular practice of organizing night sky watch for our students and their families also, so that they can enjoy seeing the planets with the help of high-power telescopes. So these are the pictures of night sky watch organized in 2018, March 2018. This is in October 2018. This is in October 2020. We could not conduct night sky watch during the lockdown, and again we conducted night sky watch in 2020-21. So in order to spread the scientific temperament and awareness among our students, we have a practice to celebrate days of national and international importance. We have celebrated International Year of Crystallography, International Year of Pulses, in Akshay Urja Divas, by National Science Day, by conducting various competitions, model making competitions, slogan writing competitions, poster making competitions, etc. We, during the lockdown also, we celebrated birth anniversary of Dr. Abdul Kalam by organizing poster making competition and PowerPoint competition. We also celebrated World Earth Day in April 2021 by organizing a seminar on science and technology to conserve environment by Dr. Lalit Mohan Bhardwaj, organizing poster making competition and PPT competition. We celebrated World Telecommunication Day by organizing essay writing competition where the students from all over the Punjab participated in the event. To give the experiential learning and hands-on training workshop to our students, it is our regular practice to organize hands-on training workshops almost every year. So these are the glimpses of hands-on training workshops organized in 2015, 2016, 2017, 2018 by Dr. Jaswinder Singh. 2000 again during the lockdown, we did not stop and we continued our tradition by organizing 2 days national webinar and e-workshop experimental electronics by Dr. Manish Dev Sharma. We also organized guest lectures for our students to give them new concepts to make them more. But this is a guest lecture by Dr. Inderjeet in 2019. In 2020, again online guest lectures were conducted. The students also learn by doing. They present for one presentation, they participate in poster making competitions, slogan writing competitions. So these were the competitions arranged in 2018, 2020 regularly. The Save Energy and Save Environment. We have a solar project. It's set up in the college campus by setting a 150 kilowatt solar panel in the college, saving around 75 kg of coal per day. Our outreach activities, we organize various experimental workshops for the students outside the college or the students of different schools and college so that they can have hands-on training workshops in our campus. So these are the glimpses of the one-day workshop organized on how to learn science in 2016, where Dr. Jaswinder Singh and Dr. Prem Singh, they were demonstrating science experiments. We organized Physics Expo 2020 by organizing, we conducted Physics Expo 2020 by organizing quiz competition, essay writing competition on the topic physics and its importance, poster making competition and model making competition. These are the glimpses of the model making competition and the lecture given by the Dr. Jaswinder Singh. Again, we conducted National Science Week celebration. It was a 1 week program in which all students from different schools all over the Punjab were invited to participate and learn. This is the physics department demonstrating different experiments. These are the models made by our students. These are the students of different schools participating in the event. In this science celebration also, our students also participated, and these were the 2 recent projects guided by me. I have also made one project, that is the touchless washroom based on the sensors. And presented this in the Science Week celebration. We also organize a visit of different school students to our labs so that they can also have a benefit of the high-tech apparatus we have in our labs, which are otherwise missing in their schools. So these are the glimpses of some school students visiting our labs. Based on all the activities and the academics of our college, our students participate in various competitions and bring laurels to our college. So these are the images of, this is Miss Garima, who participated in NAAC in 2017, and she got a 4th position and a cash prize of 4,000 all over India. This is the Science Fest organized at BD Arya College, and our college got the best college trophy for this competition. Our students, they also participated in National Science Day celebration at GNDU in 2019. Miss Jaspreet Kaur of our college bagged 1st position in RC2 North Region and third in all over India. She was awarded a cash prize of 3,000 book and a pen drive for her essay in the national competition of essay writing in physics. Our students also participated in national level quiz competition organized by DAV College Managing. As a result of all the pains taken by our teachers, our students reach we have many success stories. Swati Gandhi, she is a science officer in applied physics at Bhabha Atomic Research Center. Prabjot Kaur, she is working in Calgary Board of Education. Neha, she is pursuing PhD at CSIO. Radhika, she is a radiation safety officer and medical physicist. Shweta Sharma, Bhavya Mida, and Garima, they are employed in Deloitte and Wipro. So these are very few to name, and there are many more. Thank you for patient listening.
We will study about electromagnetic induction. Electromagnetic induction, as the name tells us, electromagnetic induction means induction of electric field due to the changing magnetic field. Okay? So in this Faraday who showed that whenever we change magnetic flux or magnetic field into the coil, some current is passed. Okay? Some current is produced in that particular coil. So that current was produced only because of the changing magnetic flux, as there was no source of electricity. So this coil in this solenoid, we have number of turns. It has 3,000 turns. So the wire is turned 3,000 times along the solenoid, and there is no source of current in electricity, and this is a galvanometer. Galvanometer it detects the current. Okay? It will simply show you that whether the current is there in the circuit or not. And now, as such, you can see the pointer is on the zero axis, so that means there is no current. Now, this is a simple magnet. You have already seen it so many times. One is the north pole and another is the south. Now, if I bring the magnet towards this solenoid, you will find a reflection in this solid. That's a simple magnet. That means, can you see the reflection? So this reflection shows that some current is being produced in the circuit. Okay? As such, there is no source of current. कोई हमने बैटरी नहीं लगाई, कोई हमने सेल नहीं लगाया, कोई मैंने किसी से कनेक्ट नहीं किया, कोई सिग्नल. But क्यों आ रही है? Because of the movement of this magnet. ठीक है? One. So that was the first Faraday law, that whenever the magnetic flux linked with the coil changes, it will induce an EMF in the current, which we can see in the form of EMF in the circuit, which we can see in the form of the current. यहाँ पे current की form देखेंगे, क्योंकि current produce होना कब होगा? अगर कोई potential difference होगा. जब तक कि आपके circuit में कोई potential difference नहीं आता, कोई EMF setup नहीं होती, तो current नहीं होगा. ठीक है? So current आ रहा है, क्यों आ रहा है? That means कि इसमें कोई EMF generate हुई या setup हुई, और वो कब हुई? क्योंकि motion of the magnet. ठीक है? Now first thing, that EMF is induced whenever the flux linked with the coil changes, and the second point is that the amount of the EMF is equal to rate of change of magnetic flux. This phi, we can write it as phi n, and ये क्या होता है? We already know it, and this is B dot A. Where B is the magnetic field, A is the area of the coil. Okay? And this is dot product of both. That means we can write it as B A cos theta. Magnitude of magnetic field, magnitude of the area of the coil, and the angle between the two magnets. Right? So we can change the second law. First law was that whenever the magnetic flux linked with the coil changes, EMF is produced. Okay? And second is that the amount of EMF produced, that is directly proportional to rate of change of the magnetic flux. Okay? अभी magnetic flux हमें change करना है. From here you can very easily see कि magnetic flux change कैसे हो सकता है. Since magnetic flux is dot product of we can take. So we can change magnetic field flux in three possible ways. Either we can change the strength of the magnetic field, okay? Or we can change the area of the coil, or we can change the magnetic field. ठीक है, तीनों चीजों को चेंज करके हम अपने मैग्नेटिक फ्लक्स को चेंज कर सकते हैं.
Good morning, dear students. Today we will study about lasers. Laser is the acronym for light amplification by stimulated emission radiation. So lasers, they have some characteristic properties that they are very highly coherent. They have high intensity, are very directional, highly directional, and they are highly monochromatic. They have, because of their high power also, they are capable of propagating or moving through very long distances without being absorbed by the medium. So because of these properties, they find wide applications in medical, in communication. They can be used to measure the long distances of the stars and the sun using communication. They can be used for optical, fiber optic communication also. They can be used in medical sciences for operations or for detections also, for curing some particular diseases also. So because of these properties, they find applications in many different fields. But before starting for their applications in detail, we will study their basic phenomena behind them. So we will start with the understanding of principle of laser. So laser, that is light amplification by stimulated emission of radiation. So that means radiation will be emitted by stimulated emission. So this emission will be possible only if there are the electrons in the high energy state and they will move to the low energy. So for this, we have some particular processes that are responsible for this phenomena. The first is the stimulated absorption, then stimulated emission, and spontaneous emission also. And for these stimulated emission, the most important things that are required for the stimulated emission to take place is the population inversion, and the optical pumping is required for stimulated absorption. So we'll start with the first phenomena, stimulated absorption. Now let us consider that the material has two energy levels, E1, lower energy level E1 and high energy level E2. So if the electrons are in low energy level and a photon is incident on the material having energy equal to the difference of the two energy levels, then that particular photon will be absorbed and the electron will be shifted to the higher energy state. So this is the process of absorption. That means absorption of radiation by the electrons present in the material. And this absorption is possible if and only if we know that the principle is obeyed, that the energy difference is equal to the energy of the photon is equal to the difference in the two energy levels which are involved in the phenomenon. So because this absorption requires some stimulus from outside, that means बाहर से हमें कोई ना कोई photon provide करना है. Without providing any photon, absorption will not be taking place. So this absorption is called stimulated absorption, and this is a one-to-one process in which one photon will excite one electron into the higher energy level. So this is not possible that if we have a photon having energy double the energy difference of the two energy levels, two electrons will be emitted. It is not like that. So the energy of the photon should be exactly equal to the difference in the energy level from the two energy levels that are involved in the phenomena, and one photon will excite one electron to the higher energy level. Now the second is, once the electrons they are excited to the high energy level, then they will be automatically have the tendency to move back to the lower energy level, because the lower energy level there is a vacancy created in the low energy level, and hence any electron in the normal energy states, we already know that any electron, if it is in the excited state, it cannot stay there for a time more than 10 raised to power minus 8 seconds. So spontaneous emission is the phenomena in which the electron which is excited to the higher energy level, it gets de-excited to the lower energy level or the grounded state by the emission of radiation. That means whenever the electron is de-excited from higher to energy level, the difference of the energy is emitted in the form of radiation, and this emission process or is called spontaneous emission because this doesn't require any irradiation of the material. हमें बाहर से कुछ भी नहीं देना पड़ता है, कोई एनर्जी सप्लाई नहीं करनी पड़ती है. Provided we have electrons in the high energy state, they will be spontaneously coming back to the ground state. So such an emission is called spontaneous emission, and the energy of the photon emitted in this case will be again equal to the difference of the two discrete energy levels E1 and E2, where E1 is the energy of the ground state and E2 is the energy of the higher energy. So this will not lead us to the laser. The emission which can help us for the generation of laser is the stimulated emission. Now this stimulated emission will be possible if and only if the first condition is that the high energy level should be an energy level which has a lifetime more than the 10 raised to power minus 3 seconds. Generally, such an energy level is called metastable energy level. And if we excite the electron from the ground energy state E1 to such an energy state E2, which happens to be a metastable energy level, then this electron will stay there for a time much longer than 10 raised to power minus 8 seconds. And this time is generally closer to 10 raised to power minus 3 seconds. So this means once an electron is excited from the ground energy state E1 to the metastable energy state E2, this electron will be staying there for a time nearly 10 raised to power minus 3 seconds.